let me put up 52 for you from your homework, and then I'll show you track rule real quick, and I'll be ready. So they give you this graph. And they tell you that, I'm not going to give you this point because I'm going to show you what they say. They say this is y equals square root of x, and then they say this is y equals x squared, 317. Find the area of the shaded region. So it's two different graphs hooked together. Tell me what to do. You split it up. That's what we've been doing. Split it up. That's exactly right. Where am I going to split it? Where they meet, right? Right here is where I'm splitting. How do I know what that point is?
Find distance.
Yep. Y'all think about
that. Wait, it's probably like,
without a calculator, how could you find where two different?
oh, you can subtract them from each other. Well, can you do that?
You're kind of sort of.
Like, can you do something?
Y'all are way too deep with this. Way too deep with this. What's happening at that point?
Oh, it's a trapezoid.
What? Tell me what's what is special about this point right here? They both meet. So that point exists on both graphs. Agreed? So the square root of x is the same thing as x squared at that point. Yes? So we could solve it from there, and we could solve it that way. Now, if you couldn't see, most of these you'll be able to visually see. I just want to show you. I do want to show you a trick on your calculator. If you don't know this trick already, this will be a handy trick for you to have. If you go in your calculator and you type both of these in y equals, so square root of x and then x squared. Just do a standard zoom on them, a zoom 6. Yep. Second trace again. You don't want to find it that way. You want to actually calculate it. Go down to intersect, which is number 5. Let's go. Okay. Okay, you got both of them entered.
It's 1-1.
You zoom 6. Yeah. All right. Second trace, 5. Around intersect. And then if all you've got is 2 graphs on there, you've just got 2 equations, you just hit enter, enter, enter. Oh, no, we got to scroll up. That's because there's 2 intersection points. Okay, so when you hit intersect, scroll the little spider a little closer to where they intersect. Just have it somewhere close to the intersection point you're looking at. And then enter, enter, enter. Yeah, should get it. Embarrassing. It's 1-1. Okay. So either way you did it, that would work. You could go through. If I'd solved this algebraically, obviously I'd square both sides, right? X equals x to the 4th. So 0 equals x to the 4th minus x. Factor out x to be 0 or 1. Okay, anyway, I can tell I lost y'all on that. But anyway, the point that I'm getting to here is we have to find this place because I can't just do the integral from 0 to 2 because there are 2 different functions here, right? So I have to split it. So tell me how I'm going to split it. Tell me what integrals would give you the area. 0 to 1 of the square root of x plus, then I'm going from 1 to 2 using what function? X squared. I'm not going to work that out for you. I'm going to leave that for you because I want to set one more up for you before I show you track rule. Yeah, this was just a little piece I left hanging from last week. I love these kinds. Okay, pretend like that's nice and even. Find the area of the shaded region. And I'm just going to we're going to set the integral up together, and then I'm going to let you work on it for homework, because we only have a couple from this section to do. Just so you can kind of get the feel of what we're doing here. So talk me through it. Find the area of the shaded region.
Oh, I know what you do. Find the area of the rectangle.
Okay. Divided into three regions?
No, you're going to have to do a lot of work on it.
You think? Okay, so Stella says the two areas where it touches. Tell me what you mean. So here to here. But remember, are you talking about doing an integral? Okay, tell me what, set it up.
I don't know how to do it.
No, because it's sine. You're on the right track. It's not a semicircle, I'll tell you that. Say that again. For what? Plug it in for what? You're getting there. Plug it in for sine. What are you doing when you... Tell me what you're doing. Okay, I think you're finding the height. You're finding the height so you can find the area of the rectangle. Is that what you're doing? Okay, now notice something about the rectangle too. The rectangle's white, it's not shaded, right? If I find area under the curve, I'm going from curve all the way down, right? So if I do integral...
So find area under the curve and subtract it. Right?
That's exactly right.
Oh my gosh.
So how, okay, so what I could do, I could find the area
Oh my god.
of all that, yes? And to find the area of all that, that's just the integral, right? That's the integral from pi over 6 to 5 pi over 6 of sine x. But then I have to subtract that rectangle out. So y'all were on the right track. Y'all were thinking, I know I've got to find the area of the rectangle, and you do. Yep. So to find the area of the rectangle, remember it's length times width. This is an easy one because that across is 5 pi over 6, 4 pi. How do you? How are you going to find the height?
Oh, you can you use the calculator?
Nope. I know that the length is 2 pi over 3. How am I going to find the width or the height here? Yeah, that's exactly right. Plug it into the equation. That's why I have that equation there. This point is 5 pi over 6, and then whatever I get whenever I plug 5 pi over 6 in sine. Or I could use pi over 6 if that's easier.
Yeah, do that.
They should be, since it's a rectangle, they should give me the same answer. So pi over 6, that's your first one. Sine is your height. So which one's small? It's a smaller height, right? So is it square root of 3 over 2, or is it 1/2? Which one's smaller? 1/2. See what we did there, though? How we took the area and subtracted. on 6 on here. But we're almost done with it. But I'm thinking about skipping something and then tomorrow on another day. I'll let y'all know.
I'm talking about.
Several. Whoa. I put this on your calculator for you. No, it's a lot like RAM. Yeah. Yeah. I really want a good. All right, let's just do. Let's say I have x squared, which is just my parent parabola, right? And I want to estimate this using trap rule with 4 intervals. So here's what I'm going to do. I'm going to think about this a lot like RAM and how I set it up. So let me just graph it and show you what this looks like. Here's x squared, exaggerated a bit. I'm going from 1 to 2, and I want 4 intervals. Okay, so if I want 4 intervals, that means my width each time needs to be what? 0.25, because I'm going to do max minus min divided by how many intervals I want, which is going to give me 1/4. Everybody okay there? So 1 1/4, 1 1/2, 3/4, and then I got 2. So here are my 4 regions. But instead of squaring them off, what I'm going to do is I'm going to make them into trapezoids. In other words, I'm going to use the actual points for each end of the bounds, and then I'm just going to connect them. You see how this is a better estimate? Not as much over or underestimate there. But I also have trapezoids each time. Do you agree? Tell me how you find the area of a trapezoid. One half the height times base 1 plus base 2. And so I'm going to even condense this a little bit to say I could write this as h over 2, base 1 plus base 2. Would that make sense to you? Okay. Now, if I wanted the area of this one using trapezoid, this very first trapezoid right here, the area would be the height. How am I finding the height? I got to plug it in, right? And it's x squared. So let me go ahead and do that for all these points. This would be 1, 1. 1.25. What's 1.25 squared? 1.5625. This one is 1.5. 2.25. Most of these that you get asked are in the form of a table where they give you the values already, and you have to do trap rule 1. What is consistently the same for every single trapezoid in here? Remember, my trapezoid's on its side, right? The distance between